I've got a couple of more questions here. I think this one's probably, no, we'll give it to both of you, but Karsten can go first. How do you handle the conveying of a blend of materials that has a wide range of particle sizes or densities at the same time, and obviously taking into account separation? How do you deal with that?
Well, I'm specifically not going to refer to lean phase conveying. I would keep away from it if you can. We've burned our fingers on applications in the past on that. The problem is that your different density materials, which potentially are your different products that you have in different particle sizes, do tend to start separating out in the actual conveying line as it goes. They then end up in your silo and they start stratifying in the silo itself, and now you have a non-homogeneous blend of materials in the end, which is not really what you want to do if you're packing soup mixes after that, because then you have more salt in one bag than you have in the other. So you can do it if you reblend afterwards, but obviously that's an energy intensive process. So what you really want to do if you're looking at something like that is to convey those materials separately, each one in its own pipeline, to the actual station where you want to get it to, and then blend it afterwards. So that's one of the ways of looking at it, or going to something like a dense phase system. And Henrich, I think you can elaborate that. That is most probably the better way of doing a blended mix in the end.
Yeah, I think I also want to say there's two scenarios for that. One where we get off inquiries quite often, where I'll say dense phase pneumatic conveying or batch conveying then really outshines, is say in a batching plant you have different mixes that needs to go into the same receiving vessel. So for instance you're offloading cement, so now you're conveying this powdery puffery material, but the very next one is you need to convey pico through the same system. So although you can do it through the same system, in the background you are still also have a different control system for it. You need to tell that system that, listen, now you're busy conveying another product. And generally what we tend to do is we have different orifice plate setups or different pressure regulator settings. You open your back pressure a bit more, or if you have an automated pressure reducing valve, you have it on a different setting. And then you convey different materials. With regards to material that has different, say, particle size distributions, so if you go from very fine to very coarse, what generally tends to happen is those particles actually interlocks, and then you just form a plug or a blockage, and you struggle to convey them. If you have material that doesn't, I'll say, differ that much in particle size, you still get the separation of the different sizes. But I think the advantage there with dense phase, because you're pushing slugs down the line, you tend to pick up all the material that falls off behind the slug, and you just convey it with the next cycle. So overall, you don't really get a separation of the different sizes, but or say per batch, you will definitely leave some coarse material behind in a pipe. And because of the nature of the low velocity, there will always be material left behind in the pipe. And I think when you say, let's take a sugar plant, if you convey it with dense phase and you go to 3-4 meters per second, there's no way you can clean that line. You actually need to have a sequence of putting in a lot more air to blow it clean. Or you need to go to lean phase to make sure you clean the pipe after every batch, because you can't just leave material in the pipe for the next day or for the next week. It becomes a health issue.
Thank you, Henrich.